Okay, so let's look at a problem where you are given a table of values. We have consecutive integer inputs. And what I mean by consecutive integer inputs is that it's going up one by one by one. Okay, those are our independent variables. And then we have our output values, our dependent variable, which is changing depending upon what x is. Here the problem asks us to determine the consecutive integer intervals of x, which a zero must exist. And so we are going to be using what is called the location principle in order to answer this problem. And what the location principle says is that if between two consecutive integers of x, our output y changes signs. So in other words, it starts off, we have got a y value that's positive, and then immediately after that it flips over to negative. Then that means that there must be a zero located between those two consecutive integers of x. And that's all it is. So let's actually look at this table here. My x values are consecutive. They're counting up by one. So I'm going to focus just on my outputs, my f of x values, or my y values. Here I've got a positive 2, positive 1, negative 2. Here there is a flip in signs. So that means between the interval of x equals negative 2 and x equals negative 1, there has to be a zero between these two x values because my output is crossing the x-axis. It's going from positive to negative. Okay, so I know for sure that between x equals negative 2 and x equals negative 1, these two x values, there has to be a zero between those two x values because my outputs changed signs. I went from positive to negative. So let's keep on reading this table. Here's a negative output, negative output, negative output, positive output. So again, we have switched our signs for our outputs. So I know that between x equals 1 and x equals 2, there has to be a zero between these two values because my outputs crossed over from negatives to positives. The only way that can happen graphically is if there is a zero or an x-intercept. So my second interval here is x equals 1 and x equals 2. And then my remaining output value, it stayed positive. So there was not another change in signs. So I only have two consecutive integer intervals where a zero must exist between, those two values of x. Now let's go ahead and just look at a graph to help make this a little more concrete. I do understand the table can be a little bit hard for kids to follow. So let me pause this. I'm going to draw a graph. Okay, so I went ahead and unpaused the video. I've drawn my coordinate plane. Here's my x-axis. Here is my y-axis. Let's go ahead and plot these points that are given to us in this table. So when x is negative 3, our output y is 2. So I'm going to go back from the origin 3 units, and then I'm going to go up 2. Well, my goodness. There we go. When x is negative 2, y is 1. When x is negative 1, y is negative 2. When x is 0, y is negative 3. When x is 1, y is negative 4. When x is 2, y is 1. And when x is 3, y is 2. Now, I am not the best at freehanding graphs, so I'm going to go ahead and just try my best to, well, my pencil just broke. Boy, this is not good. This is a wonky graph, that's for sure. Now, this is not modeling any real function. I just simply had written down some consecutive integer values for x, and then I picked some random values for my output y. So forgive my not so fancy looking curve here, but anyhow, the moral of the story is we're trying to figure out the consecutive integer intervals of x, where a zero must exist. When you have a graph, it's really stinking easy to see where zeros are. I mean, here's a zero, here's a zero. And then what two whole number values, or integer values, excuse me, do those zeros exist between? Well, for this first 0, furthest to the left, I have x equals -2 and x equals -1. This is my first consecutive integer interval in which I am guaranteed to have a 0 exist. And again, it's because my output changed from positive to negative, so I crossed that x-axis. Okay, and then my second interval, occurs between x equals 1 and x equals 2. Between these two consecutive integers, I definitely have a 0 because my output when x was 1 is a negative value. And then my output when x is 2 is a positive value. So the only way I can cross over from negative to positive is if I cross the x-axis, which means a 0 does exist.